All right, so for today's lesson, we are going to learn about factoring. We will use this concept almost every single day in this class from here on out. It's going to be a really, really, really important concept that we talk about this year. Okay, so the first thing I want to talk about is the definition of what factoring is. So, the process of changing a sum to a product is called factoring. Okay. And in this class, we're going to be talking about factoring quadratics. Okay. So, we know the standard form of a quadratic, we've talked about this before, is ax squared plus bx plus c. Okay, we know that is the standard form. Well, that is a sum because we have plus signs. Factoring is changing this into a product, which would look like parentheses multiplying together with numbers inside there. That is called the factored form. And that's the product. As we know, product is an answer to a multiplication problem, and these are being multiplied together. So that's the product. So we have the sum equaling a product. This may look familiar from when we did area models. We had something that looked like this, and we changed it to look like that. Well, now we're going to go the opposite way. So we're just going to start off with an example. Okay, so our example 1 is going to be to factor x squared plus 5x plus 6. Okay? And we're going to go through this step by step. Okay, so I'm going to be writing steps over here, and I'm going to be writing the work over here. That way, when you have to do your own examples, it's really clear what you have to do. Okay? So, our first step is going to be to make an area model, which we've done that a lot before. So, we're going to make an area model just like we normally do. Okay, we have our area model. Our second step is to put the first and last terms in diagonal boxes. Okay, so in this case, the first term is x squared, and that's going to go in that box. The last term is plus 6, and that's going to go in the box diagonal. So you'll notice that those are in diagonal boxes. Step 3 is going to be to multiply the diagonal. And I always like to draw a circle or an oval around what I'm multiplying. That will just clearly show me what is being multiplied. Well, here it's going to be x squared and plus 6x. Well, that will be plus 6x squared. You don't necessarily need to write that plus. I just do so I can clearly see which sign I'm looking for. Okay. Step 4 will be make an x and put the middle term in the bottom. Okay, so what that's going to look like is I'm going to make an x. Okay, around that 6x squared. And this middle term is going to get put into the bottom. So that's a plus 5x. Now, step 5 is the most important part. So, step 5. We need to find what multiplies to the top term, or top, just the top of the x, and adds to the bottom. Okay, so we're multiplying to this and adding to this. Then those two numbers are going to get put right here. Okay, so let's think about this for a second. We're multiplying to 6x squared and we're adding to 5x. Multiplying to 6x squared, adding to 5x. Think about that for a second. So, the first thing you should think about is what multiples of 6 there are. So what multiplies to 6? Well, 6 times 1 and 3 times 2. Those are the only ones that multiply to 6. Okay? So hopefully you guys realize that it's going to be 3 and 2. So this is going to be a 3x and a 2x, right? 3x times 2x is 6x squared. 3x plus 2x is 5x. Okay? Now once you get those numbers, you're going to put them those numbers in the other diagonals. So I'm going to put 3x and 2x. It doesn't matter which one you put where. Okay, you'll get the same answer. You can always put the signs here if you'd like. That could probably help you, because when you get negatives, it's a little bit harder to figure out. And then our last step, step 6, is going to be to find the greatest common divisors. And what that means is you're going to look and you're going to see what the biggest number that both the numbers go into. Okay, so let's look. We have x squared and we have 3x. X squared, 3x. What do they have in common? They have an x in common, so we're going to write an x right here. Then we have 2x and we have 6. 2x and 6. What do they have in common? A plus 2. X squared and 2x, they have an x. 3x and 6 have a 3. That's your factored. Those are your factors, I should say. X plus 2, x plus 3. Let's go ahead and write those. X plus 2, x plus 3. And you can write equals your original, which is x squared plus 5x plus 6. And that's going to be how you factor. Okay? You just write these over again inside parentheses, equaling your original, and that's going to be your factored form. Okay? What I'm going to have you do is I'm going to write your next example down here at the bottom. I want you to do it. The video is going to pause. I want you to put your own answers in, and then you can go ahead and watch my solution. Okay? So, example 2. . is going to be 3x squared plus 10x plus 8. And again, you're just factoring. Okay, so the video is going to pause. Go ahead and do it. And then now I am going to solve it. And I'm not going to write the directions again because you already have them. I'm just going to go by. I am going to use the same colors as I did so you can see which step I'm on when. First thing I'm going to do is make my area model. Okay, I put my first term in this diagonal, last term up here. I multiply the diagonals. I make my x. The 10x drops down in the bottom. So now I'm multiplying to 10x, I'm multiplying to 24x squared, and I'm adding to 10x. Multiplying to 24, adding to 10. Hopefully you guys got that that's 6x and 4x. 6x times 4x is 24x squared. 6x plus 4x is 10x. So that's going to be 6x and 4x. Now we need to figure out our factors. 3x squared and 6x, those have a 3x in common. A 4x and an 8 have a 4 in common. 3x squared and 4x, those have an x in common. And then 6x and 8 have a 2 in common. Okay, now you can always check your work by going like this. 3x times x gives me that 3x squared. 3x times 2 gives me that 6x. 4 times x is 4x, and then 4 times 2 is 8. So you can check your answers doing that. So I have 3x plus 4 times x plus 2 equals my original 3x squared plus 10x plus 8. And I'm all done.